A magnificent material, versatile, cheap, environmentally friendly. I'm speaking about plastics. They can be molded into virtually any shape, be produced with comparatively low efforts, and avoid CO2 emissions from transportation when used in cars or packaging due to their low weight. However, plastics also cause negative environmental impacts. Greenhouse gas emissions arise from their production and end-of-life incineration, or if plastic waste is not collected, it may cause severe harm by ending up in the environment. Recycling can mitigate these problems related to plastics. This is my research field. I'm Magdalena Klotz, a PhD student at the Chair of Ecological Systems Design of ETH Zurich, and I investigate how to increase plastic recycling in Switzerland. Today, in Switzerland, only 10% of all plastic waste is recycled. The rest is almost completely incinerated for energy recovery. I got these results from conducting a so-called material flow analysis. With this analysis, I determined which amounts of different plastic types are used in different applications, their recycling rates, and the applications of the secondary plastics gained. Based on the system analysis, I tried to understand why plastics are not more widely recycled. One cause is that today plastic recycling is very often financially not convenient. Another reason lies in the technical challenge posed by the immense variety of different plastics. This diversity enables product properties perfectly targeted to certain applications, but at the same time unavoidably leads to a mixing of different plastics at recycling, of different colors from different applications, containing different additives, unless literally 1 million plastic fractions are separately recycled. The consequence of such mixing is that the recycled plastics have a gray color or that their properties are not fit for any specific end use. Therefore, a large share of the secondary plastics are today only used in lower demanding applications, such as boxes, drainage pipes, non-visible car parts, or flower pots. To increase the applicability of secondary plastics, I align the design of plastic products in future scenarios that I model for reducing heterogeneity without compromising functionality. I also model marker-based sorting, which allows to separate different plastic waste fractions based on a freely chosen number of properties. I compare different scenarios based on their environmental impacts, which I determine with a method named life cycle assessment. My goal is to design future plastic recycling scenarios that allow for reducing CO2 emissions and preserving fossil resources. These recycling benefits can be one contribution allowing us to keep enjoying our modern lifestyle that is also enabled by plastics.